Hello everyone and welcome to YouTube Model Builders. I want to say go to YouTubeModelBuilders.com. There you can check the schedules for the show. The Tuesday and Wednesday shows are at 8 o'clock Central, 9 o'clock Eastern Time. The Thursday show is at 9 o'clock Central, 10 o'clock Eastern Time. Tonight we're doing a Saturday night special. It's going to be with Chris Rood and Robert Holloman. They're going to do a DCC plus. I gotta look at Chris's slide. Bill to so those that want to just try out DCC without having to go into a bigger cost of like buying one of the manufactured systems, this is a good way of doing it. All right, at this time I'm going to turn it over to Mr. Chris Rood and let him start the show off. So Chris, it's all yours now.
Thanks, Johnny. Good evening, everybody. As Johnny mentioned, Robert and I are going to be walking you guys through the DCC++ build. Um, with that being said, there was a parts list that was distributed before the show. If you guys could tell us what motor shields you guys purchased, that would kind of be helpful, even if they're the generic ones that weren't recommended, only because the other one that's recommended tends to be a little more cumbersome. So if we know what you guys are typically using, then we can maybe skip through that other one and just concentrate on the latter. So if you guys just put that in the chat, and my co-host will do the polling for us. So as Johnny said, as we said, helps if I had it. So this is going to be a two-part series, and tonight will be part one. So what we're going to do is we're going to talk about, I don't want to call it theory, but it's going to be a little bit more um, PowerPoint based, and then there's going to be some uh, desktop stuff. So what we're going to do is we're going to talk about what is DCC plus plus. We're going to talk about what is an Arduino because I'm sure there's some people out there that have not been following the Arduino show on YouTube Model Builders or MRH. Yeah. Okay.
It looks like it's working on this side, Johnny. Yeah, so it looks like.
If you guys can hear me, we're just having a little technical difficulties. Johnny's working on it right now. Okay. Everybody's saying in the chat it's good. Mr. Crawford, Mr. Renzetti, and all these guys. So, um, as I was saying, this is going to be a two-part series. It's going to be a mix of slides, as you see on the screen now, and hands-on desktop or computer-based demonstrations. So tonight is part one. We're going to talk about what a DCC++ is. We're going to talk a little bit about what Arduino is, just for those people who don't know. We're going to talk about what the hardware is required to build a DCC++ system, the software required for DCC++, downloading and installing the Arduino IDE, downloading the DCC++ sketch, modifying it to what we need to do, and uploading it to our boards, and then assembling the base station. Okay. Before I go into the next slide, I ask that everybody keep your questions relative to where we're at within the presentation. If we don't hit something later on, we'll have time for questions later at the end of the show, or and we have places in here for questions. We'll answer your questions as we go in the building process, but I just ask all of you just to kind of stay within the show because it's easier on us and that. So And in part 2, which will be next week, uh, what we're gonna get then what we're gonna get into is um, the downloading and installing of JMRI, the setup of JMRI, its connection to DCC++, connecting DCC++ to your layout, setting up the Wii throttle or engine driver, configuring and running your first engine, and then we'll just do any additional DCC++ resources and close out the show with some other stuff. Okay. So what is DCC++? It's an Arduino-based DCC base station, which is open sourced. Okay. It was created by Greg Bierman. It was completely free to use, besides the hardware, obviously, but the software is free to use. All the software provides some functionality, same functionality or more as available a commercially available system. There's large community support developing around it, and it is used with JMRI software. Now, JMRI isn't necessarily required for DCC++, but this show is going to use JMRI. So we're not going to go outside that realm in this show. We're just going to talk. We're just going to assume that everybody's going to use JMRI, and that's how we're going to build the system. And as we go, we'll probably talk about the pros of using JMRI, and probably talk you into using JMRI. So just a fact that why is it called DCC++? Somebody asked me that in the last week in the weekly night chats, and basically what it is the developer said it's a DCC system that it's creating the DCC signals through C++ programming. But Mr. Crawford actually I added this afterwards, it also adds some additional features to your base station. So the plus plus is part of the programming that's used and some of the additional features that you get with it that we'll talk about here in a minute. So some of the features, you get 2-byte and 4-byte locomotive addressing with it, simultaneous control of multiple locomotives, you get 128 speed steps, you get your normal cab functions at 0 to 28, and you can activate, deactivate accessory functions using 512 addresses with with 4 sub addresses, including optional functionality to monitor the direction of any connected turnout. So you can also program on the mains track. You can program on the programming track, and programming on the main, you can write your configuration variable bits, set clear specific configuration variable bits. On the programming track, you could do the first two on the as mentioned on the main operations track, and also read your configuration variable byte. Also, with the DCC++ system, the you can control turnouts using the pins on the Arduino, and you can also use the pins on the Arduino for sensors. And if you use a Mega, which we'll talk about all these boards in a little bit, you can control an RGB LED light strip, which is for those that don't know, a red, green, blue LED strip. So you get multicolor LEDs in a strip. Okay. So what is an Arduino? Some people may know this, some people may not. It's a microcontroller. It's built on open source technology. It's very big in the makerspaces community. It's becoming very big in model railroading. Um, it allows you to control the physical environment, meaning that it can read buttons or sensors. It can control outputs like LEDs or motors, and so basically what it is it's a really small computer that's on an integrated circuit, and it's sometimes referred to as system on a chip. If you want, there's a ton of resources out there on model railroading on what an Arduino is. I did an article along with Andy Crawford, did some series of articles in the August 2017 EMAG for YouTube model builders. You can check them out. Model Railroad Hobbyist has several articles on this topic too, if you're looking for more information on it. But I just wanted to cover the basics for now because we are going to be talking about it to get the common terminology out there. So the basic hardware that we're going to need to do a DCC++ system is just some common electrical parts, Oh, I'm sorry. The hardware that's used with Arduino are common electrical parts, Arduino boards, which is the microcontroller itself. As you can see here in the picture, um, uh, my, my mouse is all backwards on me. Right here is an Uno. There's a variety of different boards available. Some of them are official, some of them are clones, or some of them are third party. Third party meaning that they take the official concept and maybe they branch out and they add additional features to them. Uh, a shield. Again, a shield. We're going to be using what they call a motor control shield. A shield is basically, they call it a shield because it sits on top of the Arduino microcontroller, so it shields it. Um, so there's also software involved. So with an Arduino, there's what they call an ID, it's integrated development environment. So what we use this program to do is if you're going to write a custom program for the Arduino to read a button or read sensors, debug the code, and then what we do is we're going to flash the code, or you can say maybe upload the code for those of you that may not understand the flash. Um, Arduino uses C++ programming language, and the sketches are the files that are used by the IDE, and the sketches are uploaded to the Arduino board to tell it what to do. So we're not going to program anything in DCC++. What we're going to do is we're going to download a sketch. We're going to open it up in the IDE. We're going to configure a couple things, and then we're going to upload it to our boards, and then we're done. So what the hardware is required for the DCC++ system, you need an Arduino board. A certain type is required. You need an Uno or a Mega, and they can either be official or clones. You need a motor control shield. I recommended the official Arduino one only because so there was less of any problems during the build of the show. That's what I have. Or a Palulu Dual MC 33926 motor shield. They're the two recommended by the creator of DCC++, excuse me, and jumper wires. So I'm gonna really quick show you. I'm gonna transition uh, to my desktop camera, and I'll show you really quick. Johnny, can you switch the screen really quick so I can show? Okay, so this is this is an Arduino Uno. Okay, so this is an Arduino Uno, and this is your Mega. So this is a shield, the motor control shield for that fact. So you can see, you don't have to do anything now. I'm just showing you for kind of proof of concept. And that just mounts right on top of that. So it just kind of shields the main board.
Chris, hang on. The
See?
stream just went down. Yeah, it just went offline. All right. Good.
Okay. John, you could go back to the PowerPoint real quick. I was just trying to. Okay. Okay. So, um, and are you going back? Okay. Are you going back to the? Oh, okay. Because I didn't get there yet. On the problem is I'm following it on YouTube, and it's yeah. So, okay. So, what's the difference between an Uno and a Mega? For what we're doing today, nothing. Um, when in the future, when you're talking about permanently putting this on your layout, the Uno only gives you 14 digital input output pins, 6 analog pins. It's more commonly used for DC C++. Where the Mega gives you 54 digital input output pins, 16 analog pins, has more memory than Uno, and but it is required to use with DCC++ if you're going to use the Ethernet shield, which means you're going to connect DCC++ to GMRI via the Ethernet, or you're going to use the LGB light strip. for this, like I said, for this build, it doesn't matter which one you use because we're not going to even talk about the Ethernet connection. We're just gonna use serial connection directly to a computer to connect the DCC++ system to JMRI. Wait, oh, ladder. If you're gonna decide that you want to control sensors and turnouts with the system, and you need more than 14, then the Mega is your thing. But like I said, for this build, it doesn't really matter which one you use. Okay. Um, the more, like we said, the motor shield. There's the official one to the left. That's the recommended one. It requires no ring. I know a lot of people were buying clones. Robert has a clone that works perfectly fine for him. um, so that they haven't used the Palula one. I haven't seen too many people use these. Third party shield, and it also requires soldering to get it to sit on top of the Arduino because it comes with no pins on it. Okay, so now we get into the software part of this. So the software required, like we said, was the Arduino IDE. It's free. It's available for Windows and Mac, and it could be. We're gonna download it here in the show. Excuse me. At that link, and Johnny has put these links into the description of the video for tonight. I have also posted them in Google Plus and the video and the show posting and on Facebook. Excuse me. I'm suffering from a cold, so I'm sorry if I keep coughing. And then we have to get the sketch. Like I said, the sketch is the the file that's open in the IDE. So, is there any questions? Anytime? Okay. Okay. So now what we're gonna do is we're gonna go download the IDE. So we're gonna go to this link, and I'm gonna pop it up over here. So if you guys get to the screen, now I already have this on my computer, but we'll walk you through it really quick. So
for those of you that didn't have a chance to write down the link itself, you can just go into the Google search bar and just type in Arduino IDE, and it'll take you right there.
yeah, or it's in the description of the video too, as I
There you go.
mentioned. um, no, I'm okay. I'm just gonna throw. So as I mentioned, you could get this for Windows and Mac, Linux too. What I'm sure most are Windows or Mac. So if you want so I have I'm running a Windows machine right now, so I'm gonna click here, Windows installer. It's gonna ask you contribute and download. Just click it over here to the left and hit just download. You don't have to pay any money. And then just save it on your computer on your downloads folder, your desktop. I'm gonna put it in my downloads folder for right now. So we're gonna download it.
We just dropped. We're back.
Finish downloading. I'm gonna go open on my over here to my bottom of my browser. It's gonna open it. Do you want to verify it, Arduino? Yes. See, it's telling me that I have to, uninstall this. But just kind of, it's pretty simple. Just kind of walk yourself through. It'll install on your machine. Just give them a couple minutes. As you guys are installing that, I'm just gonna. back to here. Hide this. Are you guys? Yeah. Okay. And again, the links for all this stuff will be in the description of the show. Apparently, Johnny's having trouble with that too because of the drop. I'm trying to. So I'm gonna assume that everybody's pretty much caught up. If not, just post in the chat if you're still downloading the IDE or whatever. So the next part of this is what we have to do is we have to download the physical sketch. So this is the program that we're gonna actually put on the board, and that's gonna make the DCC++ system. So, oh, I already was there. So when you come here and here, I mean, let me kind of blow this up a little bit so everybody at home can see it. So when you come into GitHub, and you don't have to, don't worry, don't be afraid of this. You're gonna see a big green button over to your right here. You go download zip file right here, click it. And again, I'm gonna put this in my downloads folder just for the lack of better places to put it. Okay, so I'm gonna go show folder, and I'm gonna right click on this, and we're gonna extract this. Make sure you just extract this to a folder. Extract to base station master. So I see how I extracted mine to here. So we're gonna click that folder. Okay, and then you're gonna see here there's another folder in there called DCC pp_uno, the sketch, PDF, and a README. We're gonna open up that Uno file. Now the Uno, it's called DCC ++_Uno because when he originally created this, he created it for the Uno, but this is the same file that we would use if we were running a Mega. So don't be scared. So what we're gonna do is if your IDE is set up, we're gonna open this. We're gonna open this file right here, the DCC ++_Uno. Let me see here. Unfortunately, I can't get my screen to zoom, but it's just the one you'll see the little blue or green Arduino symbol to the left of it. Double click that. It's gonna open up the IDE, and if anybody's having problems, just put in the chat so we can stop, because this is supposed to be a group session here. Okay. So so we have the IDE open. Here's the sketch. Okay. And let me just kind of fumble back here to my slides. So my slides are my script, I guess you can say. So we did this. We opened that up. So now what we're gonna do is we're gonna configure the sketch before we upload it. Okay. So you can see up here in the sketch, you have the one file we open, and it's bringing in all these other sub files, and there's tabs along the screen. What we want to do is we want to go to configure.h, which is right here, which is it's the fifth tab over from the left. Okay. It's config.h is the tab. So once we're in here, we just got to edit two things. The first one being is right here, which just says motor shield type. Okay. So right now there's a 0. If you're using, I'm going to say if you're using a motor shield, which is the official one, or it has a chipset of L298P, you're going to want to put 0 in there. or if you're using the Palua one, you're going to want to put a 1. So if I was going to use a Palua one, I knock that 0 out and put a 1 in there. Or as I'm using the official one, I'm going to put a 0. So the next one in, what we want to do is we want to do the common interface. So this tells the program how we're connecting to a JMRI or another source that could send commands to the base station and tell it what to do. So like I said, there's more. You can use Ethernet cards. So he has this built in, and if you're going to use Ethernet, you have to use a Mega. Did it go offline again, Johnny? Okay. So is okay. So what we're gonna do now is I'm gonna flip back to my desktop really quick. Okay. And I'm not gonna use my Mega. I'm gonna use my Uno just because probably that's what most people are using. And like I said, it doesn't matter, but just for sake of the show. So what we're gonna do now is we want to connect our board to our computer. So yeah, yeah, sure. I just have to go back to the ID. Okay. Let me just get rid of this here. Okay. So you guys didn't get the config. So as I mentioned, when you open up the file, the 5th tab over from the left is going to say config config.h. Okay. In that config, we need to configure 2 things. One is the motor shield type. So it's right here at the top. Okay. And I'm assuming that everybody's probably using um, the Arduino motor shield or a clone. So you're going to set that to 0. If you're using the Palua one, you're going to want to set this to be 1. And I'm just going to change it to show you 1. Otherwise, it's 0. The next one is define communication interface. So as I mentioned for this show, we're only going to use serial, but we can use Ethernet to connect DCC++ to JMRI or whatever you're going to use to send the commands. So if I was going to do that, I would send it to 1, but I have to use a Mega board for that. But for this show, we're going to set that to 0. So really, you don't have to really change anything. I was just kind of going over for future reference what would need to be changed in the future. There's other things that would need to be changed, like IP addresses and other stuff for Ethernet purposes. But that's all has to get changed. So I'm going to switch back to my desktop, and what we're going to do now is we're going to connect the Arduino to our computer, and then we'll upload the sketch. Ron, I said I had to set the interface com. Just leave that to be 0 if you're using serial. Okay. So you guys can see my screen or my tabletop. I'm sorry.
In this case, serial is going to be US.
Yeah, it's just your USB connection. Just leave it 0. So what we're going to do is in case you guys never have done this, this is the USB cable. You need a type B connector on one, and I believe this is called an A. Oh, this is the A. I'm all backwards here. This is the A. This is the B. Okay. The B goes into the Arduino because it's usually a B type connector that's typically on these. Sometimes they're micros, depending on what board you buy. If you buy a newer board or whatever, but whatever. Yeah, I have this blue one here. This is a cheap. I got these boards from China, and they came with these cables. They work. They're cheap China tables, but we're gonna connect this in to here, and then this. Now we're gonna connect this right to our computer, and it doesn't matter if you go to a hub, you plug right into your tower, whatever. Okay, so I'm gonna do that. You're not gonna see my screen. And Johnny, while I'm doing this, you could go back to sharing now from my desktop. Okay. Sorry to make you keep flipping and flopping, but okay. So my board is now in my USB hub. Okay. So if you're unsure, what we need to know is if in the IDE, if you go to Tools and you go to Port, okay, see how it has COM1 and COM4? See how it says COM4? There's an Arduino Genuine Uno. That's the one that we want to select because that tells the IDE what USB port the board's plugged into to flash the DCC++ system in. So we go to COM4, we select that. We also need to go into boards, and we need to make sure that we have Arduino Genuine Uno selected. In my case, I already had it selected. Now, what I should have mentioned was in port, if you're using a Mega like Ron Strange and Things, he's going to have come up a Mega, okay? And under boards, he's going to want to select, let me see here.
Arduino Mega ADK.
Yes, the Arduino Mega 80. No, I'm sorry. The Arduino Mega 2560, genuine Mega or Mega 2560 is the one you want to use. Excuse me. Okay. So depending on which one you're using, you need to tell the program what board you're using and then what COM port that board is on. So I'm on COM4 with my Uno. With the board I'm using, I'm selecting an Uno. If I was using a Mega, I would select the Mega or Mega 2560. Okay. So now that we did that, if everybody has their boards plugged in, your computer's finding them. We selected the COM port in the program, the type of board we're using. And now what we're going to do is usually when you write your own software, you need to verify it. I'm not going to do that because this has been verified already by the author and we didn't change anything. So I'm just going to hit upload. So you could just go up to the top of the screen here and see this arrow that points to the right in the circle. When you hover over it says upload. When you click that, it'll upload to the board. You could also go to, let's see, I gotta remember myself. Sketch upload. I just used the arrow though right here. So if you just hit that, that's okay, Ron. We're still chugging through this, so just keep going, and if you hit a snag, we'll get you back up to snuff. So that's uploading now.
And generally speaking, the first time you upload, it's going to take a little longer than subsequent uploads will.
Yes.
I'm panicking just because it's taking an extra minute.
Yeah. Because what the program actually doing is compiling the sketch, and it's actually going to verify it because we didn't verify it to begin with. So, it's kind of doing some stuff in the background. So, mine is, let's see here, mine is done uploading, and it uploaded fine. I know it says in my IDE invalid library found or whatever. but that's just common errors that I have on my machine. So is anybody having any tafus or anything that we need to handle before we go any further with this? Okay. I just don't want to go ahead of them. And so so now we have DCC++ on our Arduinos. That easy. Done deal. So now what we need to do, when we go back to my handy dandy notes here. So we're done with that. We uploaded the sketch. So we didn't really have any questions. So now we can basically assemble our base station. In the sense that we're gonna unplug the board from the computer. Okay, and you could do that once it's done. Just unplug it. You're not gonna hurt anything. It's not like it's a Windows machine, and if you unplug it from the power and you don't safe reboot, you're gonna hurt something. And then and then we can basically after that connect to the computer, which we're not gonna do today because right now we're just gonna do the build. We're gonna do that next show. But there's a couple things though before we start assembling this that we're going to talk about in terms of the motor shields. Robert, did everybody pretty give a poll on the motor shields or?
We basically got one person's waiting on theirs to arrive. Didn't say what it was. The other one said they have a name brand.
Okay, so
nobody's went with the pool.
okay, so I'm going to skip I'll basically brief over the pool a little bit, but I'm not going to spend too much time on it. I'll spend time on the 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 official one, which is going to be clone wise. It's very similar. So the one thing to note though, that there's going to be two diagrams for each motor shield that we're talking about. Where one is for the Uno and one is for the Mega because of the pins. Okay. So this one I have up on the screen right now again is for the Uno. So how DCC++ works is basically it uses PWM pins to get the DCC signal into the motor chip to send it out to the railroad. Okay. So as you can see here, and we're gonna do this on the desk, but as you can see here, we have the jumper pin 10 to pin 12 on the motor shield, and we have the jumper which is for the DCC main, and we have the jumper pin 5 to pin 13 programming. Okay, but the board also uses several other pins. Okay, it's part of the motor shield, and they're signified by the square red dots. Um, the other ones with are just red. They're not solid red squares. They're reserved for DCC++ unless the brake trace is cut, and I'll show you that here in a bit. And then the rest of the pins are basically available. Analog pins, and I didn't really tell you what an analog pin was, but an analog pin basically is something that is used to measure like voltage or maybe amperage. So DCC++ uses analog pins A0 to A1 to measure how much this motor shield is pumping out from its supply and what it's pumping out on its output on the A and B channel. So, what was that?
Sure thing.
Okay. So, as you could see, so we talked about the pins a little bit. So, as you can see on the motor shield, you have the DC, yeah, what's it me? DCC, the DC power supply coming in. And then you're on the A channel side of the motor shield, you get your main ops track, And on your B side, you have your programming track. So that's what comes out. Um, so if we go to we'll go to the Uno, the Mega side now. Basically, you get the same thing, except that the programming. Where's the? Oh, where's the? So you let me just catch my bearings here. So you have the jumper 2 to 13 for the programming. You don't have the jumper. I guess we don't have to jump or anything. I'll verify that when we get there. That we don't have to put another jumper into this. But again, there's pins reserved for the DCC system, and all these are available in that PDF in that download we did. When in here, I'll show you guys. So that zip file, that the Arduino sketches. You just open it here. Oh, it's not in here. I'm sorry. I apologize. I'll show you where to get it though in 2 seconds here. I thought it was in there, but it's not. So if we go back to the GitHub page where we originally downloaded it, and if you click here on DCC++, so base station is the one we were just in. If we go to documentation, which is here, you see motor shield pin mapping .pdfs. We open that up, and of course it opens it up here. Let me go back and open it on my machine so it's not. Well, anyways, they're all here, and they explain everything so that when you go to build this in the future, you know where those diagrams are coming from. I just put them right in my PowerPoint. So apparently, there's only one jumper needed for when you use the Mega because the other two are already internally jumpered. So the key thing here is that we have to, and it's recommended, is that the VN connection, which you see here in the red, that you cut that trace. And what that does is basically when you put 12 volts of power or more in that motor shield, it keeps that 12 volts isolated to the motor shield only, and doesn't feed. It doesn't feed your Arduino more than 12 volts, because if you feed the Arduino more than 12 volts, you're going to fry it, because the voltage regulator on it is only good for about 12 volts. So I cut mine. I recommend anybody cut theirs. And then you just would power your Arduino board individually from your motor shield. So like a PC power supply or the computer, you can even power it from the computer you're using, as long as you're not using any of the pins for LEDs or turnouts or any of that. That gets a little crazy than trying to use a 5-volt power supply off a USB cable. But like I said, a lot of guys like Robert, they build power supplies using old PC power supplies. You can take the 5-volt line bus from that and feed this guy. The tendency on the Arduino boards is you start feeding them a lot of power, their regulator tends to get hot. So I would try to keep it low. The other thing too is if you're going to use like servos on this, make sure you power your servos independently and not through the pins. So typically guys like to use like 15 volts, possibly if they're running HO, 0 and 3, 0 and 30. So um, I don't put that I wouldn't put that much power in. I would put maybe 11, 12 volts into my into my motor shield, and then boost my main out. Um, Now the other the brake disable, you don't have to cut that trace. Okay, that's only if you want to use those 8 and 9 pins like it says here. So right now for this build, if you don't have to cut them, but if you're gonna do this show and you're gonna run trains along with us, then I recommend that you cut that VN. And all you have to do is and Johnny, I'm gonna go back to my just to let you know, I'm gonna go back to my desktop quick. Okay, so it's going to be really hard to see, okay? But so here's my motor shield, okay? So on the side, this side where these headers are, you'll see if you flip the board on their side, you'll see a jumper called VN, and I'm going to point to it. Let me flip this around really quick here. So yeah, I'm trying to, but it's so small. I'm trying to get in on it. So yeah, so it's right here. So what you do is you just basically take like an X-Acto knife, even, and you just want to break those traces. And it's really hard for me to show you that, but you'll see two little pads there, and they have to get broken. So basically, what that does is isolate the VN of the physical Arduino board, the microcontroller, from the VN of the motor shield. So you just rub them away. You scratch that away. You break that, and then if you're so like I said, so they don't backfeed. What I did to make sure mine didn't backfeed is I tested it one night with a multimeter, and I made sure that um, my VN wasn't getting it was getting 0 to make sure my traces were cut. Uh, well, I so what I did was is I basically mounted, and we'll mount this in a minute. But what I did was I used the VN pin and the ground pin to measure that wasn't anything coming off of that motor shield. Or what you could even do too is you could do continuity too, I believe, and across those two. And if you don't get anything, they're cut. Um, so that's my heap on that. I would cut the trace and be done with it, and then just feed your. I don't use my DCC push system with the pins for anything. I just use it as a base station. So I don't have no problem feeding the board, you know, by itself and uh, the motor shield separately too, because I'm only using it for the DCC signal. Um, so let me just so if nobody has the let's Johnny, just jump back to my screen quick. We'll talk about this pool really quick. So okay, so the pool one is basically the there's more um, jumpers that need to happen. Um, it gets kind of messy because if you're doing a permanent setup, you may want to solder. You got to solder headers to this to mount to the physical microcontroller or the Arduino. Um, I'm not going to go too depth into this because it seems like nobody's using it. Uh, um, so, but just make note the same um, the same source I showed you. These diagrams are in too. So. Uh,
Yeah, Ron. I see that your clone motor shield doesn't look anything like that on the back. Join us in the in the chat afterwards. Walk you through it.
Yeah, Ron, don't worry about cutting that trace right now. Just don't feed any power into your board, which we won't get that step anyways tonight anyways. So, but we'll walk you through that later on. Okay. The developer use DCC. Yeah, I wouldn't put any more than 16 volts into that either. That's correct. I wouldn't even put 16 volts into it. I would probably max at 12 or 15. I'm just answering
Yeah,
what
I wouldn't
Mike
put any more
Morris.
than a 12 on it.
Okay,
The reason I would stick with 12 is because if you go past that, you're gonna burn out your Uno or
yeah,
run
well
the
you
potential to it.
you don't. That's why you cut that trace. So if you don't
Right.
have a trace, if you don't have a trace, then you're pretty much limited to 12 volts or lower. But if you have a trace, it's basically what the motor shield's rated for. So some of them are rated, probably up to 20 volts because they're a motor shield. Um, but I tend to lower my voltage in, and then I would recommend putting like a Tam Valley booster on the other end of my main to boost the voltage back up to send it back out, so that I didn't have to feed my shield that much power. Because all you're looking for this thing to do is get the DCC signal into your voltage, your DC positive side. So um, so what we're gonna do now is we're gonna build this. So I'm gonna okay. So Johnny, just put me back to my camera quick. So I'm just gonna go back here really quick. So we want to do now, since we have this uploaded, okay, we're gonna mount this to here. So we're gonna take our Uno and we're gonna mount our motor shield onto it. So 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 the orientation of the boards, okay. See where this USB? No, don't put the screwdriver to it while it's powered. But where this USB connector is, you want the headers of this to be oriented with that. So with the USB connector. So what we're gonna do, all we're gonna do is we're gonna take our motor shield and we're gonna line the pins right up with the holes on the Uno or the Mega. I'll show you the Mega in 2 seconds. I wish I had two motor shields for this because that would be helpful. You could do both of them. Okay, mine's in there, so now it's mounted. So on the Mega and on the Mega, so it's the same thing. So you're gonna orient it like this, and you're gonna mount the motor shield like so. So basically what happens is, if you see this, I didn't lock mine all the way in, you're gonna have extra headers here because the the shield works on the Mega, but because the Mega has extra pins, you're gonna have a little longer open area at the backside, where this board on the Uno covers it right up. Okay, so why I'm here, because this only requires one jumper, which is the program jumper, and I'm following the diagram here. So I'm going to use the red one. So what we want to do, again, here's my USB. So you're gonna come all the way over to the end of the motor shield. You're gonna look to where my wire, the side closest to you guys, which is the camera side. We're gonna go. You're gonna see pin 0, pin 1. We're gonna go pin 2. And again, this is only for the Mega. Okay, so we're gonna jump a jumper in a pin 2, and then we're gonna go to pin 13. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there, that's jumpered. So see how I did that? I just put a male jumper in there. So then that one's done. So I'm gonna take this apart really quick because now we got to do the Uno. So I'm gonna go and mount this back on, and again they're oriented where the USB connector and the jumper. Just to iterate that again. Okay. So on this one, we have to put 2 jumpers in, right? Like we talked about in the thing, in this slide. So for my programming, I'll use red again because we just used it on the thing, on the Mega. So now what we're gonna do is we need a jumper from pin 5 to 13. Okay. So again, the side closest to you guys in the camera, we're gonna look for pin 0. Okay. And then we're gonna go all the way up to pin 5. Okay. So that would be the 6th pin up from 0 because we have 0. And then we're gonna go to pin 13 from there. So if should be the 5th one down from this side right here. So that's our programming jumper. Okay. So now we need to do our main. So we're gonna go to pin 10 now. So pin 10 is gonna be that going from the 13 that we just plugged in. It's gonna be 3 pins down. Oh boy, my jumper wire is a little sketchy. And then that's gonna go to pin 12. So it's gonna run next to 13. So this is where it gets a little here. Here we go. So, and I apologize. So my yellow one is actually the programming one, and the red one's actually the main. I used the wrong ones, like I said. But that's essentially it. That's how that's assembled. This is ready to be hooked up to JMRI and hooked up to the layout right now, the way it sits. Assuming that you cut the trace after you cut the trace. Let me up that a little bit so you guys can see it. So let's see here. So is there any questions up to this point? Because there's nobody has anything. Does anybody have any problems besides drawing? Wow. Yeah, I see that. Yeah. Well, that's the end of part 1 then. And like I said, part 2 Robert's gonna be talking to a lot of you where I'm gonna be in the background, coursing him. But we're gonna download the JMRI. We're gonna set up a JMRI connection to DCC. We'll connect DCC to the layout. We'll set up the V throttle, Y throttle, whichever way you want to say that, or your engine driver if you're running an Android. We're going to configure and run in your first engine, and then we'll talk about DCC++ and how it's growing in the open source railroad community, because there's different other variations that have developed since this was released, and I just want to mention them for people so they don't think that you have to use JMRI. I'm only going down that road here now because it's the easiest to get people going with this system. I think I use JMRI. I think there's a lot of benefits to using JMRI. and a lot of guys like Robert are using Jammerai. And I think if you see how easy it is to program an engine in Jammerai and get it going, um, uh, you'll start using it. Even if you just use the Decoder Pro function of Jammerai and you don't use Panel Pro, it's very makes life very easy. Um, but we'll recap a little bit as we go further and next week, and we'll go from there. If you guys have any questions in between now or then, just hit us up on Google Plus or to Facebook, or if you come in the weekly chats, just ask away. We'll be around. So at this time, I'm going to turn it back over to Johnny. He can close the show out, and I appreciate everybody for coming in and listening to me for an hour chat about this, and I hope you guys picked up something out of it.
Thanks for joining us, everybody.
Okay, it does help to turn my microphone on so everybody can hear me. I did notice Sparky out there. Yeah, you're right. It is a lot of information. I'll have to watch this video myself a couple of times because my motor shield board hasn't come in yet. But it seems like a lot of information, but once you get it set up, it's actually pretty simple. You sit there and go, well, that wasn't all that bad after all. So do appreciate everybody coming in. And be sure to tune in next Saturday night, March the 17th at 8 o'clock Central, 9 o'clock Eastern Time for part 2 and the finish up of the DCC++ build. Probably recommend that if you are building these, maybe get you a section of flex track, 3-foot section. That way you can hook your power leads up with alligator clips and just to check, make sure that the engine is running. Everything's running right for you. You don't need to run it too far just to see. So with that said, go to YouTubeModelBuilders.com. There you'll find the schedules for all the shows we're doing and the specials. The Tuesday and Wednesday shows are at 8 o'clock Central, 9 o'clock Eastern Time. The Thursday talk show is 9 o'clock Central, 10 o'clock Eastern Time. We got another show next week, March 13th, which is this coming Tuesday. It's going to be the Fine Scale Show with Andy, Ralph, and Miles on their build that they've been working on. So appreciate y'all coming in tonight. Have a good weekend, and we'll see you Tuesday night. So goodbye.